Let's look at how translations and transformations and reflections are shown in exponential functions. This is the graph of f of x equals 2 raised to the x. It's got the usual point 0, 1. It's got the point 1, 2, 2, 4, 3, 8. Let's compare it to the graph of f of x equals a negative 2 raised to the x. If we look at the graph of f of x equals a negative 2 raised to the x, and now this is the negative of 2 to the x. This is not the base negative 2. The base is still positive 2 raised to the x, but this is the negative of it. How would that look? If we take the negative of 2 to the x and make all of the y values from here negative, it reflects it over the x-axis. We now have the point 0, negative 1, 1, negative 2, 2, negative 4, 3, negative 8, and so on. What if we took the graph of f of x equals 2x minus 10? So 2 raised to the x minus 10. What's the minus 10 going to do? If we take all of the values of 2 to the x and we subtract 10 from them, it drops the entire graph down 10 units. We now have, instead of the point 0, 1, we have 0, negative 9, because it got dropped down 10 units. This one comes down 10 units. This is a distance of 10. This is a distance of 10. From here to here is 10, and so on. So the entire graph has been dropped down 10 units. What happens if we add or subtract something to the exponent prior to raising the 2 to the exponent? In other words, what about the graph of f of x equals 2 raised to the x minus 4? So the whole exponent is x minus 4. Now, do you recall what subtracting 4 from the x will do to the whole graph? In this case, it moves the entire graph 4 units to the right. Because now, when we put in the 4, we get 2 to the 0. When we put in 5, we get 2 to the first. So the points have now jumped over to 4, 1, and 5, 2, and 6, 4. So everything has gone 4 units to the right. What does a combination of some of these things do? How about the graph of f of x is 2 raised to the x minus 4 minus 10? What if we combine this graph with this graph? So we take this graph, 2 to the x minus 4, and subtract 10. There it is. Now remember that these are a unit of 10 along the y-axis. So the graph of f of x equals 2 to the x minus 4, this one, minus 10 takes this graph and drops everything down 10 units. And finally, let's clear some of these out. Finally, what if we took the graph of f of x equals 2 to the x minus 4 minus 10 and made the 2, put a negative in front of the 2. That reflects this graph, flips it over so that all of these, now notice that is now reflected across the line y equals negative 10. So all of the translations, transformations, reflections work the same with exponential functions as they do with anything else.